We are page 216. Page 216, polynomial functions. Today is 16 January. And we are in example 4, right? Evaluating the graph of polynomial function. We are on page 216, guys, okay? Yeah. That density, you know the density, you took it in physics, I think. Yeah, the density of the sun or chemistry of the sun in grams per centimeter cube expressed as a percent of the distance from the core of the sun to its surface can be modeled by the function, and this is the function given in front of you. F of x equal 519 x to the power of 4 minus 160 or 30 1630 x power 3 plus 1844 x power 2 plus 889 x minus, not a plus, right? Minus 889 x plus 155. Okay? Where x represents the percent as a decimal. At the core, x equals 0, and at the surface, x equal 1. Okay? Done. What's the function? This function, read the question, you understand what we are talking about. The question said, the distance from the core of the sun to its surface. You know the core of the sun? It is like inside the core. Yeah. We have core of earth also, right? The center. Let's say the center of the surface to its surface. The center of the sun means if this is the sun, the center inside, this distance modeled by this function. Okay? Done? It's not our work to understand these items, by the way. Our work is to represent the function. This function, how we name it, how we name this function. It is a polynomial of degree what? How we name this function. If I want to now to give this function a name, how we name it? Huh? It's a polynomial of degree 4. We took linear, we took quadratic, cubic, quartic, quintic. So it is degree 4. It is a quartic polynomial, right? We took that before the vacation, remember? So what is the leading coefficient? It is 519. This we call it the leading coefficient. The degree, the highest degree is 4. And this function is written in standard form, starting from 4, the degree, then 3, then 2, then 1 on x, and the 155, we call it degree 0, right? Guys, I'm talking about things, we took them before the vacation by 1 day, I think, right? Then, find the core density of the sun at a radius of 60% of the way to the surface. So x here given by 60%, right? 60%. Now to substitute, we cannot substitute percent. We need to substitute value. So we turn this percent to value. 60% means 60 over what? Means 6 over, means 0.6. So they want us to find the distance at x equal what? So replace x by what? F of 0.6. Replace x by 0.6. So 519 0.6 multiply طبعا power 4 minus 163 0.6 power 3 plus, and finish the substitution, the answer will be 0.6224. 0.6224. 0.6224. Okay, just replace and substitute. Is this clear? Huh? Ask me. 60%. This is from the question. Read the question. You have a book. والبوك هذا جايبينه عشان نحطه بالشنطة؟ خايف عليه يبرد يعني؟ يعني مش منطق. والله مش منطق اللي بتعمله انت. Read the question. The question wants us to find the core density of the sun at a radius 60%. So x is how much? 60%, but we cannot substitute a percent inside the function. We need to substitute real value. So we turn this radius below 60% to a real value. 60%, 60 over 100, simplified 0.6. Okay? Is this clear? Right. Now go to the check. Down, down, down. Go to the check. See it? Read يا أبو خليفات. يلا. Okay, the change of a die can be modeled by f of x equal negative 0.006 x to the power of 4 plus 0.140 x to the power 3 53 x power 2 plus 1.79 x. Also, this is a quartic polynomial. Quartic means degree what? 4, right? Continue, Zaid. Muhammad. X, ركز هون. X is what? X represents the time in seconds, right? Continue. After 5 seconds. So x is given how much? 5. So here in part A, x is 5. They want us to find this function at x equal 5. So replace x by what? By 5. So f of what? 5 equal. Replace x by 5 and calculate. So negative 0.006 multiplied by 5 power 4 plus 0.140 multiplied by 5 power 3 minus 0.053 multiplied by 5 power 2 plus 1.79 multiplied by 5. This is equal calculator. You need to use calculator here. It's difficult to use your hand. It will be 21.375. 21.375. Okay? Done? In part B, they want us to graph and select which one of them. ركز معي الآن. In part B, they want us to what? To graph this function and select which a graph of these given graphs A, B, C, or D, right? How we graph this polynomial function? This is not a quadratic function, no vertex here, no axis of symmetry, no parabola. This is power what? 4, not 2. What we took before is on power 2. Vertex, axis of symmetry, find the x-intercepts. هاي القصص وين؟ A, B, C. هذه بالquadratic. ميز. Here we are talking about a function of degree 4. How we graph it? Here we need to use what? Table. We need to use table. You choose values for x Remember, choose values for x here and find the values of y by substituting this value where? In the function, right? Then you have what? Ordered pair, صح? xy. Remember, we took this idea before. Then in your coordinate plane, you plot the points and make your graph. If you did all of these ideas or all of these steps, the most common or the most graph similar to your graph should be part A. Should be part A. In part B, the solution is part A. Got it? Select part A. Done. Done. فهمنا الidea. Now, the next idea is the zero of the function. We have something, it's very important in your life. We call it the zero of a function. For example, ركز معي الآن. Example, the zero of a function, I'm not talking about the zero as a number. It is a name here. It is what? A name. The zero of the function is a value. ركز الآن. What's the zero of the function? It is a value. If you substitute this value in the function, the answer will be zero. Got it? يعني this value makes this function equals to zero. You understand the zero of the function? This is very important. In a quadratic chapter, we call it x-intercepts. Remember? Yeah. For example, find the zeros of f of x equal x power 2 plus 5x plus 6. This is a quadratic function, right? The question wants us to find the zeros of this function. Now, to find the zeros of this function, we make this function equal 0 and find mean x, right? We solve the quadratic equation, normal. So here we take this function, x power 2 plus 5x plus 6, and put it equal what? 0. And you know, we factorize, then we solve, remember? And we know the parentheses idea. We took that before. So here, x plus 2, صح? X plus 3. And we did this a lot before. And it's very important. Revise it. You have a quiz, I think, after 1 or 2 weeks. Now, x plus 3 equals 0, right? Means x equal -3. And x plus 2 equals 0 means x equal what? -2. These two values, we call them what? Zeros of the function. What's this mean? If you replace x by -3 here, the answer should be 0. Replace mentally. -3 power 2, positive 9, right? 5 times -3, -15. -15 plus 9 be fair, -6. Plus 6, 0. And put -2 also, the answer should be 0. So what is the zero of the function? It is a value that make the function equal what? 0. In the previous chapter, we took a lot of ideas of solving quadratic only quadratic equations. Parentheses, completing the square, and the quadratic formula. Remember? وأعطيناهم حقهم أعتقد. Now, go to, and in general, ركز معي. If you want to graph this function here, which we did the zeros for, if you want to graph it, these two values, -2, -3, and -2, are the x-intercept, means the vertex, because A is positive, the vertex should be down, and the curve should be passing through what? The -2 and -3. And we took that before, right? I'm not talking about any new ideas here. صح? So, what's the new thing here? It's to find the zeros of polynomials that not in degree 2, not a quadratic. But can we find the zeros of? No, we didn't take the idea, but we can find the zeros if you have the graph. If you have the graph, The zeros are the x-intercepts. You will search about where is the graph intersect with the x-axis. This value makes the function of that curve equal what? 0. Like this -2. ركز الآن شو بحكي. This -2 makes the function of this curve equal what? Y 0. مش هون 0. Done. Now go to example 5. See example 5 in front of you. Example 5. On page 217, we have this graph. See it in your book. It's more clear. Something like this, right? Here we have 4, I think. صح? Here is 1, and here is -2, -2. Let's read the question. Use the graph to state the number of real zeros of the function. How many real zeros of the function? And here up here, what's here? What's here? Huh? I know. What is it in your graph? 4. 4 or 5 مش different. مش مهم بالنسبة لنا. Now what are the zeros of the function? We have 3 zeros, -2 and the 1 and the 4. How many real zeros we have? 3. So we have 3 real zeros. مش 3 0. 3 real zeros. These values makes the function of this graph equal what? 0. Okay? Means if you know the graph of this function, by the way, it's a cubic function, from its curve, we can know it's a cubic, but if it's something like this, quadratic, right? So here, we have 3 real zeros. What are they? X equal -2, X equal 1, and X equal what? 4. طب how about this 4 here? هذه الواي انترسبت ما لهاش دخل بالزيروز اللي هي السي سميناها. Remember? Do you understand? Good boys. Yes. رافعين ايديكم احكوا يا شباب. What? X -2, 1 4. صح؟ Yes, yeah. Yes, you can. The check, guys. Let's go do the check together. Check after this example. We have check. See it? Yeah. Use the graph to state the number of real zeros of the function. How many real zeros we have? 4. If you see the curve, just point with the curve. The curve intersects with the x-axis 4 times. What are they? -5, -3, 3, and 5, right? Put them. So here, the function has how many real zeros? Put 4 in the space. 4 real zeros, and they are x equal, write with me, x equal -5, -3, 3, and 5. Do you understand this idea? Good boys. Example 6, I don't want its idea. I know, mister, I know. أشغلتني أنت. But in the homework, we have question 1, 2, 3, and 4, right? صح؟ مظبوط. Let's check the homework and select a new one. 7, 8, 9, 10, 11, 12. Did we have them? Huh? Question 7 only. Right. Let's go to question 1. دقيقة شوي. 1 2 3 4 and 5. هذول wanted. Check your homework with me. يلا. Check your homework, please. So we are done with this lesson. Done? Yeah. Fine. Describe the end behavior of each function using the leading coefficient and degree, and state the domain and the range. We took that in 4 cases, remember? We wrote them in the board. Hope you remember them very well. So we are on page 219. Question 1, we have f of x equal 3x power 4. Here a is positive and it's even, right? Now let's imagine together. A is positive means it's open upward, right? And it's even means upward or downward. It's upward. So both are up. So as x go to positive infinity, الواي وين بتروح؟ معها. As x go to negative infinity, الواي وين بتروح؟ كمان positive infinity، صح؟ طب the domain, الدومين all real numbers, but the range y more than or equal 0, because this x bar 4 always positive، صح؟ أخذنا هذا الحكي. فاهم أنت؟ في cases احنا بنشتغل على cases كتبناهم واشتغلنا عليهم، مظبوط؟ Good. الفور cases موجودين. If you didn't write them in the first page in your book in the lesson كله موجود عندك. Okay? Or you can revise the two periods we did before in videos. Question 2, we have question 2. F of x equal power 3. ركز الآن. Power 3, we have two figures, right? Right? This or this, صح? Either upper one or the lower one. Now this, if A is positive. This, if A is what? Negative. And both in odd degree, right? If you understand the graphs, it's better to memorize the cases. يعني أنا مش حافظ الcases. أنا بس بتخيل الرسمة. Imagine the graph and just I can make the end behavior. Here A is negative, right? So I'm talking about this one. If x is positive infinity, y نازل negative. If x is negative, y طالع positive عكس بعض, right? So as x go to positive infinity, y go to negative infinity. As x go to negative infinity, y go to positive infinity, right? صح؟ Domain range always الدومين R والrange also كمان R. Gives positive, gives negative, ما فيه مشاكل. Done? هذا question 2. Copy if you didn't copy, please. Question 3. In question 3, we have f of x equal negative half x power 5. It is same of this odd with a negative, صح؟ هذه odd with a negative. So as x go to positive infinity, y go to negative infinity. As x go to negative infinity, y go to positive infinity. الدومين real number والrange also real numbers. Question 4. F of x equal 3 over 4 x power 6. A is positive and it's even like the parabola and both opens upward, right? So here as x go to positive infinity, y go to positive infinity. As x go to negative infinity, y go to positive infinity. If a is negative, ال y وين بتروح دائما؟ تحت negative infinity, right? طيب الدومين or real number والrange y more than or equal 0. If a is negative, الرينج شو حيصير؟ y less than or equal to 0, right? All of these cases are written in your book on the first page in this lesson. Done? Done. طب question 5, the question said the shape of a parabolic. من اسمه parabola يعني بيحكي عن quadratic function here. The shape of a parabolic reflector inside a flashlight can be modeled by the function f of x equal, given the function. Question 5, f of x equal 4 over 3 x power of 2, right? What the question wants, graph the function f of x and state the domain and the range. Okay, I will graph depending on our experience. Okay, so here, now what's this? This is x power 2, right? X power 2 parabola, remember? Because we have 4 over 3, it will be more wide. More what? Wide. Something like this. Done? You can use table, you can find the vertex, axis of symmetry, the zeros of the function, all of the steps we did for the quadratic function, okay? But graph the function, state the domain and the range. Depending on the case, A is positive and N is even, so the domain here is what? Or real number or range. كله فوق ال x axis, صح? Always 0 or what? Positive. So y more than or equal to 0. The domain is R and y more than or equal to 0. Next. That question 7. We'll do more than one question 7 in this idea. State the degree, the leading coefficient of each polynomial in one variable. If it is not polynomial in one variable, explain why. Not every expression is a polynomial, right? Yeah. Let's see question 7. We have n plus 8, right? The question said, state the degree and the leading coefficient. What's the degree of this function? Degree 1. What's the leading coefficient? Also 1. هذا ال1 هنا وهنا، صح؟ So degree 1 and leading coefficient. Leading coefficient is also what? 1. Right? طيب شو كمان بده؟ هو polynomial ولا لا؟ Polynomial. It's a polynomial. طيب see question 8. Look at the question 8. Question 8, we have 2x minus 1 multiplied by 4x power 2 plus 3. Okay, now before you judge on this polynomial, you need to simplify it. You need what? Simplify it. How? By multiplying them to find the whole or the standard form. Is this a standard form? No. This is standard form. This is not a standard form. So here, multiply 2x by 4x power 2, 8x power 3. 2x times 3, 6x, right? Negative 1 times 4x power 2, negative 4x power 2, negative 1 times 3, negative 3, رتبه 8x power 3 minus 4x power 2 plus 6x minus 3. This is polynomial in standard form. Now, after you find or simplify it, you can find it. What's the degree of it? It's a 3. What's the leading coefficient? It is 8. Is it polynomial? Yes. It's a cubic polynomial. Cubic means degree what? 3. Then yes, it is polynomial. Question 9. It's ready. Question 9, we have negative 5x power 5 plus 3x power 3 minus 8. Is it this polynomial? Yes. The degree of it is 5. So the degree is 5. The leading coefficient, -5. Is it polynomial? Yes, it is polynomial. ما في مشاكل يعني. Question 10. We have 18 minus 3y plus 5y power 2, okay, minus y power 5 plus 7y power 6, right? Is this in standard form? It is not in standard form. You can write it in standard form by arranging the degrees from the greatest to the least. But the question doesn't ask us or didn't ask us about the standard form. They want the degree, the leading coefficient, if it's a polynomial or no. What's the degree here? 6, the highest degree. What's the leading coefficient? 7. So his degree equals 6, leading coefficient equals 7. Is it polynomial? Yes, it is polynomial. ما فيه مشاكل. Question 11. U power 3 plus 4 u power 2 t power 2 plus t power 4. صح؟ اقرأ الكويشن up. The question said set blah 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 each polynomial in one whole polynomial, but not in one variable. You have two variables, u and t, right? If it is not polynomial in one variable, explain why. This is not polynomial in one variable. Why? Because you have two variables, u and t, right? Question 12. So not polynomial, we cannot talk about degree and leading coefficient already. So question 12, we have 2r minus r power 2 plus 1 over r power 2 also. Is this polynomial? No, it is not. This is equal to r minus r power 2 plus r to the power -2. It is in the denominator. The variable in the polynomial cannot be in the denominator. We took conditions, right, for the polynomial. So this is not polynomial. Done? You have negative exponent because it has negative exponent. If you go back to the definition for the polynomial, the exponent should be non-negative. But how we know if the exponent is negative or no? With two ways. The first way, it's already written negative. The second way, if the variable in the denominator. If the variable in a denominator means it has power negative. أخذتوا الباور negatives? Huh? Like for example, 3 to the power -5. It is 1 over 3 to the power 5. Good. Go, mister. Then only type. Question 6. How many time you have? How many minutes? طيب. Question 6, let's talk about it على السريع واكتب الانسر عندك. Okay. A company uses the function f of x equal x power 3 plus 3x power 2 minus 18x minus 4, right? To model the change in efficiency, okay, of a machine based on its position x. Graph the function and state the domain and the range. Here we have x power 3, right? A is positive and the 3 is odd. The domain is what here? All real numbers, and the range also all. شوف power 3 power 5 power odd powers هذولا الدومين والrange are always R. Okay, you can graph it using the table idea. Go down now to question 13. Question 13. Question 13, are you with me? Start. Dalen drew n dots on a piece of paper, making sure that no set of 3 points were collinear. شو يعني collinear؟ يعني on a straight line. Okay. Start. The number of triangles that can be made using the dots as vertices is equal to. You know, sometimes in Facebook you see some figures and the question said up أتحداك, right? To know how many triangles in this figure, right? This function, see it in front of you? Just replace x or n by the number of the dots. The points gives you the number of the triangles. You have the function f of n equal 1 over 6 multiplied by n cubed minus 3n power 2 plus 2n, where n is more than or equal 0. Go to part A, معلش. If Dalen drew 15 dots ولا 3 منهم on a straight line, ها؟ فاهم علي؟ 15 points. ما فيش ولا 3 منهم on a straight line. This is in the question. بقول لك how many triangles should be? Replace n by how much? 15. So replace n by 15, it will be f of 15 and find the number of the triangles he can be made. The answer will be 455 triangles. Huh? Part B, sketch a graph of the function. How we sketch a graph? How? Okay, done? Done.